16th of May, 1943. Royal Air Force Scampton, Lincolnshire. The sun set at 2100 hours, casting long shadows across the concrete aprons where 19 Avro Lancaster bombers sat in neat rows, each fitted with equipment that did not appear in any standard manual. Ground crews checked fuel lines and electrical systems while aircrew gathered in silence, studying maps they were forbidden to photograph. Wing Commander Guy Gibson walked among them, offering no speeches, only brief nods. The Air Ministry expected precision. Intelligence predicted losses approaching 50%. Yet inside each modified bomb bay hung a weapon that weighed 9,000 pounds and carried no conventional fuse. The mission brief stated simply, "Breach the dams." The crews knew what headquarters did not yet dare to admit, that what they attempted had never succeeded before and might never succeed again. In the spring of 1942, Britain's industrial strategists faced a persistent problem. German war production centered on the Ruhr Valley, where three major dams, Möhne, Eder, and Sorp, supplied 75% of regional hydroelectric power and regulated water flow to 4,700 industrial facilities. Conventional bombing had proven ineffective against reinforced concrete dams protected by torpedo nets, anti-aircraft batteries, and natural terrain barriers. Air Ministry planners calculated that destroying these structures would require ordnance that exceeded the payload capacity of existing aircraft. Yet one engineer believed otherwise. Barnes Wallis worked at Vickers Armstrong's research laboratory in Weybridge, where he spent his evenings calculating water pressure, rotational dynamics, and structural failure points. His memorandum, titled Air Attack on Dams and filed as report number B463 in April 1942, proposed a method that sounded implausible to conventional military thinking. A cylindrical bomb, spun backwards at 500 revolutions per minute, released at precisely 60 feet altitude and 232 miles per hour, designed to skip across water like a stone thrown by a child at a pond. The bomb would strike the dam wall, sink while maintaining contact, and detonate at a predetermined depth using water pressure to amplify the explosive force against the structure's weakest point, its underwater foundation. Air Ministry officials read the proposal with skepticism. No pilot could maintain 60-foot altitude at night over water. No bombardier could achieve the required accuracy of 425 yards from release point to target. No existing aircraft could deliver a 9,000-pound weapon under such precise conditions. Wallis persisted. He requested access to testing facilities and presented calculations showing that hydrostatic pressure at 30 feet depth would create shock waves equivalent to conventional explosive yields 6 times larger. If the theory worked, one bomb could achieve what dozens of high-explosive bombs could not. In September 1942, testing began at Reculver Bay in Kent. Ministry of Aircraft production cameras recorded each trial. Dummy bombs launched from modified Wellington bombers, skipping across surf at various speeds and spin rates. Early spherical prototypes tumbled unpredictably. Cylindrical designs proved more stable, maintaining trajectory across 400 yards of open water. Engineers adjusted weight distribution, shifting ballast forward to control pitch angle upon impact. Each modification brought incremental improvement. By April 1943, 32 tests had produced 11 partial successes and 3 full penetrations of reinforced concrete targets placed in shallow water. Observers from the Royal Air Force Technical Board recorded explosive force equivalent to 6,000 pounds of TNT delivered underwater, enough to fracture dam foundations if deployed with sufficient accuracy. The weapon, codenamed Upkeep, measured 60 inches in length, weighed 9,200 pounds when fully loaded with Torpex explosive, and required custom mounting hardware that no standard bomber possessed. Wallis calculated that only one aircraft had sufficient power, range, and structural integrity to carry Upkeep, the Avro Lancaster. Yet even the Lancaster required substantial modification. Engineers at Avro's Woodford facility removed bomb bay doors entirely, installing instead a special cradle that held the cylindrical weapon suspended between 2 hydraulic arms. Belt-driven motors spun the bomb to operational speed before release. Twin ALDA spotlights, mounted in the nose and mid-fuselage, projected beams downward. When the beams converged on the water surface, the aircraft was at precisely 60 feet, the only altitude at which Upkeep would function correctly. Wing Commander Guy Gibson received orders in March 1943 to form a new squadron. Number 617 Squadron assembled at Royal Air Force Scampton. 133 aircrew, average age 22. Drawn from existing Lancaster units based on skill records and operational experience. Training orders specified altitude 60 feet, speed 240 miles per hour, night navigation over water using visual landmarks only. No radio communication. No deviation from assigned routes. Absolute precision. Crews practiced over Derwent Reservoir in Derbyshire, flying at treetop height while bombardiers used rudimentary triangulation sights, 2 wooden posts attached to the windscreen, aligned with dam towers to calculate exact release distance. Pilots who could not maintain 60-foot altitude within 5-foot tolerance were reassigned. Those who remained flew practice runs every night for 6 weeks, navigating by rivers and railway lines, learning to judge altitude by watching moonlight reflect off water surfaces. Wallis attended several training sessions, observing from the ground as Lancasters roared past barely higher than the reservoir's edge. He wrote in his personal notes, "Skill, not machinery, will deliver the bomb. We have engineered precision, but men must achieve it." By mid-May, 19 aircraft had been modified to carry upkeep. 23 crews had trained to operational standard. Intelligence analysts calculated mission success probability at 10%. Strategic planners debated whether the operation should proceed at all. On April 26, 1943, the Air Ministry issued Operation Chastise, classified most secret. Primary targets: Möhne and Eder dams. Secondary target: Sorp Dam. Tertiary targets: Schwelm, Ineep, and Lister dams, to be attacked only if primary objectives were achieved and ordnance remained. Reconnaissance photographs showed Möhne Dam specifications: 535 feet long, 130 feet high, holding 140 million cubic meters of water. The structure supplied Ruhr industries with electricity and regulated river flow for barge transport. Its walls were reinforced concrete, 12 feet thick at the crest, 130 feet thick at the base. Torpedo nets extended 70 feet into the reservoir. Flak batteries ringed the structure, 2 88mm guns, multiple 20mm positions, searchlight batteries. German intelligence had anticipated British interest in Ruhr infrastructure. Defenses reflected this awareness. Radar stations at Stavern and Hampstead provided early warning of low-level approach routes. Night fighter squadrons based at Gilsrieden and Leeuwarden maintained standing patrols. Anti-aircraft units received standing orders to engage any aircraft flying below 1,000 feet, regardless of identification markers. The Germans believed their dams were protected by geography. Valleys too narrow for approach, walls too thick for penetration, nets too deep for torpedoes. They were correct on every point except one. No one had considered a weapon that skipped. Air Ministry planners studied German defensive positions through April and early May. Reconnaissance Spitfires photographed approaches to each target, identifying flak positions, searchlight locations, and potential navigation landmarks. Intelligence officers compiled dossiers on expected opposition, estimated reaction time, probable fighter response, backup defensive measures. Each dossier concluded that casualties would be significant. The mission briefing, delivered to crews on May 15, included casualty estimates that were not disclosed in full. Headquarters projected losing 8 to 10 aircraft, meaning 50 to 70 men killed or captured. No one mentioned these figures during the operational briefing. Gibson reviewed target photographs with squadron leaders. The plan divided aircraft into 3 waves. Wave 1, 9 aircraft including Gibson's Lancaster, would strike Möhne first, then proceed to Eder if ordnance remained. Wave 2, 5 aircraft would attack Sorp using different approach angles due to terrain constraints. Wave 3, 5 aircraft in reserve, would launch 1 hour after Wave 1, targeting any dam not yet destroyed or attacking tertiary objectives if primary targets were breached. Each Lancaster carried 1 upkeep bomb. Each crew consisted of 7 men: pilot, flight engineer, navigator, bomb aimer, wireless operator, front gunner, rear gunner. Fuel load was reduced to 2,000 gallons to save weight, barely sufficient for a round trip to the Ruhr and return. Flight time: approximately 3 hours outbound, 3 hours return, plus time over target. Aircraft would fly at wave-top height across the North Sea, then follow rivers and valleys through the Netherlands and Germany, avoiding known flak concentrations and radar stations. Navigation would be visual only. Radio silence would be maintained except for brief coded signals confirming target destruction. The modified Lancasters, designated Type 464 provisioning modification, differed from standard aircraft in ways beyond the missing bomb bay doors. Armor plating had been removed to reduce weight. Dorsal gun turrets were eliminated on several aircraft to improve aerodynamics. Each plane carried maximum ammunition for remaining turrets, 7,000 rounds of 303-inch for front and rear positions. The spotlights, essential for altitude measurement, drew power from auxiliary generators that ran continuously once aircraft approached enemy territory, creating additional electrical load that reduced available power for other systems. Gibson's aircraft, call sign AJG, carried additional radio equipment for coordinating the attack. Other aircraft bore designations AJM through AJZ. Ground crews painted each letter in white on the fuselage, adding no other markings, no squadron insignia, no kill tallies, no personal decorations. These were not aircraft intended for publicity. They were tools built for one specific task. On the evening of May 16th, crews assembled in the briefing room. Intelligence officers unveiled maps showing the route: northeast across the North Sea to the Dutch coast near Vlieland, then inland following the Zuider Zee, turning southeast past the Rhine, descending into the Ruhr Valley from the north. The return route would follow the same path in reverse, assuming aircraft remained flyable after encountering flak. Weather forecast: clear skies, full moon, perfect conditions for visual navigation, and for German anti-aircraft gunners. The briefing concluded at 2000 hours. Crews walked to their aircraft carrying no personal items except identification tags and escape kits. Each man knew the odds. None spoke about them. At 21 hours 28 minutes, Gibson's Lancaster lifted off from Scampton's main runway, followed at precise intervals by 8 more aircraft of Wave 1. Engines synchronized to cruising power, 1,600 revolutions per minute, as formations descended to wave-top height over the North Sea.
Navigation lights extinguished.
Radio silence. The bombers flew so low that spray occasionally struck windscreens when aircraft dipped below optimal altitude. Pilots focused on maintaining 60 feet, the crucial height that would become second nature before they reached the target. German radar at Stavern detected low-level contacts at 2300 hours but categorized them as training flights. British Coastal Command conducted regular patrols at similar altitudes.
No fighter scrambled.
The Lancasters crossed the Dutch coast near Vlieland without opposition, following the Zuider Zee inland. Below, villages showed no lights, blackout regulations enforced throughout occupied territory. Navigators tracked progress by counting bridges and railway junctions, comparing terrain features to reconnaissance photographs they had memorized. At 2340 hours, aircraft AJM, piloted by Flight Lieutenant John Hopgood, struck high-tension wires near Rees. The Lancaster's port wing shredded. Hopgood fought for control, gained altitude briefly, then crashed in flames near Haltern. 7 men died instantly. German spotters reported the wreck but did not yet understand its significance. 1 Lancaster down, 198 miles from target. 10 minutes later, aircraft AJE, flown by pilot officer Vernon Byers, encountered flak near Dulmen. 20mm rounds punctured fuel tanks and ignited hydraulic lines. The bomber disintegrated over farmland. 5 crew members died on impact. 2 were thrown clear and captured. German units recovered wreckage that included fragments of unusual cylindrical equipment, but intelligence officers could not identify the weapon's purpose from debris alone. Wave 1 continued. Aircraft AJK struck electrical wires near Borken, tearing away its ventral turret and damaging control surfaces. The pilot officer Warner Otley, maintained formation for 12 more miles before losing hydraulic pressure entirely. The Lancaster descended into trees, killing all aboard. 3 aircraft lost before reaching the target area. 21 men dead. Gibson's remaining aircraft pressed forward. At 0-10 hours, 6 surviving aircraft of Wave 1 approached Möhne Dam from the north. The reservoir reflected moonlight, creating a silver path that led directly to the target. Gibson circled once, identifying flak positions. 2 batteries on the northern tower, 1 on the southern tower, searchlights sweeping the valley. He keyed his radio briefly. Cooler. Stand by. The code word meant prepare to attack. Aircraft descended to 60 feet and aligned for their attack runs. German gunners opened fire. Tracer rounds arced across the reservoir, converging on the approaching Lancaster. Gibson's front gunner returned fire, suppressing the northern flak position temporarily. The bomb aimer, pilot officer Frederick Spafford, watched his wooden sight posts align with the dam towers. Distance closed, 450 yards, 400 yards, 375 yards. Spotlights converged on water 60 feet exact. Release. The Upkeep bomb dropped, struck water, bounced once, twice, 3 times, struck the dam wall 100 feet from the center, sank, and detonated 30 seconds later. Water erupted 150 feet into the air. Concrete fragments scattered across the northern shore. The dam held. No breach. Gibson circled and radioed. Goner 68A. Code 4. Bomb released. Target not destroyed. He pulled away to allow the second aircraft to attack. Flight Lieutenant Harold Melvin Young, call sign AJA, began his run at 0-22 hours. German flak had intensified. His rear gunner suppressed the southern tower while the front gunner targeted searchlights. Bomb release at 425 yards exact. The weapon skipped perfectly, struck the wall 30 feet from Gibson's impact point, sank, detonated. Another massive eruption. The dam shuddered but held. Goner 68A. Young transmitted. Still no breach. Third aircraft, AJJ, piloted by Flight Lieutenant David Maltby, attacked at 0-38 hours. By now, German defenders understood they were under coordinated assault. Every gun fired simultaneously. Maltby's Lancaster took hits in the starboard wing but maintained course. Bomb release. Sheep. Impact. Detonation. The dam wall cracked visibly, concrete falling into the reservoir, but the structure remained intact. Goner 68A again. At 0-49 hours, Squadron leader Henry Maudslay, flying AJZ, began his approach. His bomb aimer miscalculated release distance by 15 yards. The Upkeep struck the dam's top parapet instead of the water, detonated prematurely, and engulfed Maudslay's Lancaster in the blast. The aircraft, mortally damaged, staggered away from the target trailing fire. It crashed near Emmerich, killing all 7 crew members. German intelligence later recovered fragments from this wreck and finally understood the nature of the weapon. A spinning bomb designed to skip across water. Gibson radioed for the 5th aircraft to attack. Flight Lieutenant David Shannon, AJL, approached at 0-54 hours under intense fire. His bomb released correctly, skipped 4 times, struck the dam wall directly center, sank to 30 feet, and detonated with focused force against the foundation. The wall held, but observers encircling aircraft saw water spraying through new cracks in the concrete face. Pilot Officer Leslie Knight, AJN, attacked at 0-56 hours. His Upkeep struck adjacent to Shannon's impact point. The double shock wave proved decisive. At 0-56 hours precisely, the Möhne Dam's central section collapsed. 77 meters of reinforced concrete gave way. 140 million cubic meters of water, 340,000 cubic feet per second, thundered through the breach, carrying concrete blocks weighing 20 tons downstream like driftwood. Gibson transmitted one word, nigger, the code word for success, named after his dog. London received the signal at 0-58 hours. The Möhne Dam had fallen. Water surged through the Möhne breach at velocities exceeding 30 miles per hour, creating a wave initially 50 feet high. Villages downstream, Niederens, Wickede, Echthausen, received no warning. Civilian residents slept as the flood approached. At 0:59 hours, water struck Niederrance. Houses built of brick disintegrated. Stone structures deflected the initial surge but collapsed as follow-on waves undermined foundations. Residents who escaped immediate drowning climbed to upper floors, then to roofs, then watched as roofs themselves were carried away. German civil defense units mobilized within 15 minutes of the breach, but early responders had no equipment for water rescue in fast-moving floods. The wave front advanced at 20 miles per hour through the Ruhr Valley, following the Ruhr River's natural channel. At 0:12 hours, water reached Neum, a town of 12,000 residents. Industrial facilities along the riverbank, metalworking plants, small armament workshops, chemical storage depots, flooded to depths of 20 feet. Power substations shorted out, creating secondary explosions that lit the night sky. German reports later described the scene. Night became day. The valley glowed with electricity shorted to ground. At 0:30 hours, the flood reached Wickede. 7 bridges collapsed. Rail lines washed away, leaving ties and rails twisted like wire. Coal mines along the river, 8 major shafts and 14 smaller operations, flooded as water pressure exceeded pump capacity. Miners on night shift evacuated through emergency exits, abandoning equipment worth millions of Reichsmarks. The flood continued southwest, losing velocity as it spread across wider floodplains but maintaining destructive force through sheer volume. While the Möhne flood devastated the Ruhr, Gibson led remaining aircraft southeast toward the Eder Dam, 60 miles distant. Only 3 aircraft carried unexpended bombs: AJG, Gibson, AJL, Shannon, and AJN, Knight. The others departed for home, low on fuel and carrying only empty bomb cradles. Navigation to Eder proved more difficult than to Möhne. The approach valley twisted sharply, requiring pilots to bank at steep angles while maintaining 60-foot altitude. Hills rose 400 feet on both sides, creating turbulence that threw aircraft off approach paths. The Eder Dam had no flak batteries. Its remote location and difficult approach had convinced German planners that aerial attack was impractical. This assessment proved incorrect. At 0:39 hours, Shannon began his approach, aborted due to turbulence, circled, and tried again. His second approach succeeded. Bomb release at 425 yards. The Upkeep skipped twice, struck the dam wall, sank, detonated. Massive spray, visible concrete damage, but no breach. Shannon pulled away. Gibson attacked at 0:51 hours. His Upkeep struck 40 feet from Shannon's impact point. The combined explosions created structural failure. At 0:52 hours, the Eder Dam's central section collapsed. A breach 93 feet wide, 70 feet deep. 202 million cubic meters of water erupted through the opening, following the Eder River downstream toward Kassel. The flood reached Hemferth within minutes, destroying a power station that supplied electricity to Kassel's armament factories. Further downstream, water struck Felsberg, Guxhagen, and Bess, each town unprepared for sudden inundation. Knight's aircraft, still carrying 1 bomb, orbited the Eder while Gibson radioed London. Dingy, the Eder codeword, at 0:54 hours. With both primary objectives destroyed, Knight received orders to attack the Sorp Dam if fuel allowed. He departed southeast, navigating by dead reckoning toward the third target. Meanwhile, Wave 2 had launched from Scampton at 2300 hours, 1 hour behind Wave 1. These 5 aircraft carried orders to attack Sorp Dam, regardless of outcomes at Möhne or Eder. Sorp differed fundamentally from the other targets. Instead of a concrete gravity dam, it was an earth core embankment, sloped sides faced with concrete, but structurally dependent on compacted earth and clay for integrity. Torpedo nets were unnecessary. Upkeep bombs would not bounce effectively on the required approach angle. Instead, aircraft would attack along the dam's length, releasing bombs to strike the sloped face directly and detonate on contact, hoping that repeated impacts would fracture the earth core. Flight Lieutenant Joseph McCarthy, an American serving in the Royal Air Force, led Wave 2 in aircraft AJT. His route paralleled Wave 1's track, but with worse luck. At 05 hours, aircraft AJB struck high-tension wires near Ham. The Lancaster crashed, killing 5 immediately. 2 crew members survived with severe injuries and were captured. At 21 hours, aircraft AJH encountered a flak concentration near Dulman. The same battery that had destroyed AJE earlier. 20mm rounds shredded the Lancaster's tail assembly. Crashed near Borken. All died. McCarthy pressed on with 3 aircraft remaining. At 46 hours, he reached Sorpe Dam and began his attack run. The approach required flying along the dam's longitudinal axis, maintaining exact altitude while bombardiers aimed at the sloped concrete face. McCarthy released his upkeep at 48 hours. The bomb struck the dam face, detonated on impact, and blasted a crater 20 feet wide in the concrete facing. Water seeped through, but the earth core held. McCarthy transmitted Goner 58C, partial damage, no breach. Pilot Officer Warner Otley, flying AJC, approached at 59 hours, but was forced to abort due to ground fire from previously unidentified flak positions on the dam's northern approach. He circled and tried again at 101 hours, released his bomb, but the weapon struck short of the optimal impact point. Detonation created secondary damage adjacent to McCarthy's crater, widening the breach in the concrete face, but still the core held. Water leaked through at increasing rates, approximately 200 cubic feet per minute, but structural collapse did not occur. The 5th aircraft of Wave 2, AJE piloted by Pilot Officer Jeff Rice, never reached Sorpe. While crossing the Zuider Z at wavetop height, Rice's Lancaster struck water. Not wire, simply water, during a momentary altitude miscalculation. The impact tore away the upkeep bomb and damaged the ventral fuselage. Rice maintained control, climbed to safe altitude, and returned to Scampton with battle damage but no casualties. His crew had been fortunate. Knight's Lancaster, diverted from Eder, arrived at Sorpe at 102 hours. With fuel running critically low, he made one approach, released his upkeep at 103 hours, and scored a direct hit adjacent to previous impacts. The earth core fractured partially. Water flow through the damaged section increased to approximately 500 cubic feet per minute, enough to cause concern, but not enough to constitute a catastrophic breach. 3 bombs had struck Sorpe. The concrete face was shattered across a 70-foot section. Water leaked steadily, but the dam had not fallen. McCarthy transmitted final assessment. Goner 58C. Returning base German engineers would later calculate that 2 more direct hits would have caused total failure. The bombers had no ordnance remaining. By 103 hours, 8 Lancasters had been lost. 56 men were dead or missing. 11 aircraft returned toward Scampton, flying at wavetop height to avoid German fighters now fully alert and searching. Flight Lieutenant Maudslay's damaged Lancaster, still airborne after the premature explosion at Möhne, struggled homeward with control surfaces barely functional. At 112 hours, his aircraft struck a pylon near Emmerich and exploded. 7 more men dead, bringing total losses to 63. The returning bombers crossed the Dutch coast between 101 hours and 102 hours. German night fighters, launched from Gilsrieden and Leeuwarden, attempted interception but failed to locate targets flying at extreme low altitude. Flak batteries along the coast fired blindly at engine noise, achieving no hits. The Lancasters climbed to 1,000 feet over the North Sea, finally safe from ground fire, and turned northwest toward England. At 103 hours, water from the Möhne breach reached Frondenberg, 23 miles downstream from the dam. The flood had spread across a 2-mile front, depth varying from 8 to 15 feet depending on terrain. Rail bridges collapsed. Highway overpasses held briefly, then failed as foundations washed out. Telegraph lines fell, severing communications between Ruhr towns and regional command centers in Essen. German emergency services improvised rescue operations using commandeered boats, hastily assembled rope teams, and civilian volunteers who understood that official help would not arrive for hours. The Eder flood proved equally devastating. Water surged through the Fulda River Valley toward Kassel, destroying 11 villages partially or completely. At Hemfirth, the power station that supplied Castle's Henschel aircraft factory flooded to a depth of 18 feet, submerging generators and transformers. Engineers estimated 6 months minimum to restore function. In Castle itself, civil defense units mobilized at 02 hours after reports of approaching water, but the flood did not reach the city's outskirts until 03 hours, giving residents minimal time to evacuate low-lying areas. Industrial districts along the Fulda River flooded to depths of 12 feet. The Fiesler Aircraft Factory, producer of Storch reconnaissance planes, lost machine tools, partially completed airframes, and raw materials inventory valued at 3 million Reichsmarks. German Army Group B headquarters in Essen received first reports of dam breaches at 01 hours, but initially dismissed them as exaggerated. By 02 hours, reconnaissance aircraft confirmed both Möhne and Eder dams showed massive structural failure. At 03 hours, Wehrmacht commanders ordered emergency deployment of construction battalions to begin damage assessment and immediate repairs. Albert Speer, Reich Minister for Armaments and War Production, received notification at 04 hours while at his Berlin office. His diary entry, written the following morning, recorded, "Power loss severe but brief, morale shaken, not production." The assessment proved partially accurate. Immediate electrical generation capacity in the Ruhr dropped by 43%. Approximately 400 million kilowatt-hours lost in the first week following the raids. This figure equaled Berlin's entire monthly consumption. However, emergency power redistribution from coal-fired plants in the Rhineland compensated partially, reducing industrial losses to approximately 19% of normal output. Factories producing steel, ammunition, and synthetic oil experienced temporary shutdowns ranging from 3 to 11 days. Some facilities never regained full production capacity due to ongoing water supply disruptions. More significant than immediate production loss was the psychological impact. German civilians had believed their dams invulnerable. The sight of shattered concrete and empty reservoirs, photographs circulated despite censorship efforts, demonstrated that even massive static defenses could be overcome. Intercepted intelligence reports from the SD Security Service noted morale decline in Ruhr cities, Essen, Hagen, Dortmund, Bochum. Workers questioned whether other infrastructure was equally vulnerable. Absenteeism increased by 11% in the week following the raids, though this figure returned to normal within 3 weeks. British newspapers received official announcements at 07 hours, 3 hours before the first returning aircraft landed at Scampton. Headlines read, "Dams burst in the Ruhr, the Ministry of Information released carefully censored details. Primary targets destroyed, mission successful, casualties moderate. Actual loss figures, 8 aircraft, 56 dead, were not published. Instead, press releases emphasized technical achievement. Precision bombing succeeding where conventional attacks had failed. Newsreel footage, hastily compiled from reconnaissance photographs, appeared in cinemas within 3 days, showing aerial views of breached dams and flooded valleys. The film, titled The Dambusters, became one of the war's most celebrated propaganda pieces, though it omitted mention of German casualties or the mission's limited strategic impact. In Germany, censorship worked more effectively. Official statements described local flooding incident caused by terrorist bombing of civilian water supplies. Newspapers received instructions to minimize coverage. Radio broadcasts made no mention of the raids until May 19, when a brief announcement acknowledged damage to hydraulic installations in the Ruhr and Fulda districts. Photographs of destroyed dams were classified. Nevertheless, information spread through word of mouth. Refugees from flooded areas arrived in neighboring towns with first-hand accounts. Workers in Ruhr factories discussed production disruptions. The truth could not be entirely suppressed. Hitler personally reviewed damage reports on May 18. His response focused on preventing future attacks rather than rebuilding destroyed dams. He ordered immediate installation of anti-torpedo barriers, metal nets suspended from floats, positioned to prevent skipping bombs from reaching dam walls. These barriers, though conceived too late to protect Möhne and Eder, would protect other dams throughout Germany. The order reflected admission that the British had developed effective technology against infrastructure previously considered invulnerable. Within 1 week of the raids, German construction battalions began rebuilding Möhne Dam. Speer personally directed Operation Wiederaufbau, reconstruction operation. 7,000 laborers, including forced workers from occupied territories, worked 12-hour shifts hauling stone, pouring concrete, and rebuilding shattered sections. Material prioritization meant other construction projects ceased. Defensive fortifications, U-boat pens, airfield expansions, all delayed while resources flowed to Möhne. The dam was rebuilt within 12 weeks, an engineering achievement that demonstrated German industrial capacity even under wartime strain. Yet those 12 weeks cost Germany 10,000 man-days that might have built coastal defenses or repaired bomb factories. Strategic analysts later calculated that while the raid caused limited immediate production loss, it forced permanent reallocation of labor and materials to dam defense. Approximately 10,000 workers assigned indefinitely to protect hydraulic infrastructure against future attacks. British intelligence assessed operational results in late May. Strategic bombing survey analysts calculated that for every pound sterling spent on the raid, approximately £3.5 million total, Germany spent nearly £2 repairing damage and implementing defensive measures. Approximately 6.5 million Reichsmarks converted to equivalent value. The cost-benefit ratio satisfied Air Ministry planners, though debates continued regarding whether the mission's propaganda value exceeded its tactical impact. Wing Commander Gibson and surviving crew members received medals in a ceremony at Buckingham Palace. The Victoria Cross went to Gibson, Distinguished Service Orders and Distinguished Flying Crosses went to others. 56 families received posthumous notifications. 3 men remained in German captivity. The flood's human cost emerged gradually through German civil records and post-war research. Initial casualty estimates varied wildly. German authorities reported fewer than 100 deaths in official statements, while internal Wehrmacht documents recorded approximately 476 confirmed dead, 112 missing. The actual figure fell between these extremes. Comprehensive post-war analysis documented 1,209 civilian deaths directly attributable to the Möhne and Eder floods, with an additional 347 deaths from indirect causes, exposure, injuries sustained during evacuation, infrastructure collapse in the days following. Among the dead, 476 were foreign forced laborers housed in camps near the Möhne River. These workers, primarily from the Soviet Union and Poland, lived in barracks deliberately constructed in flood-prone areas, reflecting German authorities' disregard for their safety. When water struck at 0:59 hours, most camps had no warning systems. Barracks doors were locked from the outside, standard procedure to prevent escapes. Survivors later testified that guards fled immediately upon hearing the flood approach, leaving prisoners trapped. Those who broke through doors or windows faced fast-moving water in darkness, with no knowledge of local terrain. Few survived. German authorities made minimal effort to rescue foreign workers. Civil defense focused on ethnic German civilians. Bodies recovered downstream received cursory identification, often none at all, and were buried in unmarked graves near where they were found. Official casualty lists, compiled in the weeks after the raids, frequently omitted foreign victims entirely or listed them in separate categories with minimal detail. This deliberate undercount served propaganda purposes, allowing German officials to minimize apparent damage from British bombing while simultaneously portraying the RAF as targeting civilians indiscriminately. British intelligence did not initially understand the disproportionate impact on foreign workers. Reconnaissance photographs showed flooded areas but could not distinguish between German civilians and forced laborers. Post-raid assessments focused on industrial damage and military casualties rather than civilian deaths. Not until post-war investigations did researchers compile comprehensive casualty figures. These findings complicated moral assessments of the raid. The intended targets were industrial infrastructure and German military capacity, but the actual victims included hundreds who had no involvement in German war production and were themselves prisoners of the Nazi regime. Beyond immediate casualties, the raids created long-term infrastructure challenges. The Ruhr Valley's water management system had been carefully engineered over decades to regulate river flow, prevent seasonal flooding, provide industrial cooling water, and maintain navigable depths for barge transport. Destruction of Möhne and Eder dams disrupted this entire system. River flows became unpredictable. Industrial facilities that relied on steady water supplies faced intermittent shortages. Coal mines required constant pumping to prevent flooding from groundwater. Disrupted river flow affected pump operation. These cascading effects persisted for months. German engineers prioritized Möhne's reconstruction because it regulated water for the Ruhr's western industrial district, the heart of steel production. Rebuilding began on May 19, barely 3 days after the breach. Initial surveys showed that while the central section had collapsed, the dam's foundations remained largely intact. Engineers designed a replacement section matching original specifications. 130 feet high, 12 feet thick at crest, 130 feet thick at base. Concrete pours began in June and continued through August, using materials diverted from other construction projects. Wehrmacht soldiers provided labor, supplemented by forced workers from concentration camps and prisoner-of-war camps. Conditions were brutal: 12-hour shifts, minimal food, inadequate safety equipment. Injuries were common. Deaths went unrecorded in official logs. The rebuilt Möhne Dam was completed by September 23, 1943. Speer attended the completion ceremony, where he delivered a speech emphasizing German resilience and engineering prowess. He did not mention that reconstruction had required halting work on Atlantic wall fortifications and delaying expansion of synthetic oil plants, strategic priorities that might have affected the war's outcome more significantly than Ruhr water supplies. The opportunity cost of rebuilding dams never appeared in official reports. Eder Dam reconstruction proceeded more slowly. The structure's remote location complicated material transport. Damage assessment revealed that foundational fractures extended deeper than initial surveys indicated, requiring more extensive repair. Reconstruction did not begin until July and was not completed until January 1944, 8 months after the raid. During this period, the Fulda River Valley experienced seasonal flooding that destroyed crops, damaged roads, and disrupted transport. These effects, while less dramatic than the initial flood, had cumulative economic impact that exceeded immediate losses. Sorp Dam, damaged but not breached, required different repairs. The concrete facing was replaced across a 90-foot section, and the earth core was reinforced with additional compaction and drainage improvements. This work proceeded intermittently through late 1943 and early 1944, constrained by limited available labor and materials. The dam remained operational throughout, albeit with reduced capacity and heightened monitoring. German engineers installed pressure sensors and seepage measurement equipment to detect potential failure indicators, technology that had not existed before the raids. While engineers rebuilt dams, German military authorities implemented defensive measures to prevent future attacks. Anti-torpedo nets, ineffective against skipping bombs, were replaced with floating barriers positioned 400 yards upstream from dam walls. These barriers consisted of vertical poles anchored to the lakebed, connected by horizontal cables, designed to intercept any projectile traveling above or across the water surface. Additional flak batteries were installed, 4 88mm guns at Möhne, 2 at Eder, 2 at Sorp, plus multiple 20mm positions. Searchlight density increased threefold. Smoke generators were positioned to obscure dams during air raid alerts. These measures required permanent stationing of approximately 1,000 soldiers per dam, forces that might otherwise have served on the Eastern Front or in Atlantic defenses. The defensive buildup validated British strategic assessments. Even if the raids caused limited immediate production disruption, they forced Germany to divert resources indefinitely to protecting infrastructure that had previously required no defense. This reallocation represented strategic victory of a kind that could not be measured in tons of steel or kilowatt-hours of electricity. German planners now faced the reality that no structure, however massive, was invulnerable to precision attack. The psychological shift affected defensive planning across all infrastructure categories. Railway bridges, viaducts, canal locks, power stations, all received additional protection. Each protective measure consumed resources and manpower. Hitler's personal involvement in dam defense reflected the strategic impact. He viewed the breaches as a technological challenge to German engineering prestige. His orders to prevent future attacks included directives for research into advanced detection systems, improved flak control radar, and even proposals for deploying fighter aircraft equipped with searchlights for night interception of low-flying bombers. Few of these proposals reached operational status, but the effort expended on planning and prototyping represented additional opportunity costs, research resources directed away from offensive weapons development. British propaganda exploited the dam's symbolic value extensively. Newsreels, radio broadcasts, and newspaper articles portrayed the raids as demonstration of British technological superiority and airmen's courage. Gibson became a public figure, interviewed extensively, awarded the Victoria Cross, sent on morale-building tours. His celebrity served strategic purposes, convincing British civilians that bombing campaigns could achieve decisive results, and signaling to neutral nations that Britain retained offensive capability despite years of defensive warfare. The actual limited strategic impact of the raids, acknowledged privately by Air Ministry analysts, remained classified. Public perception mattered more than tactical reality. In this context, Operation Chastise succeeded not through industrial disruption but through forcing resource reallocation, demonstrating technological innovation, and providing propaganda victory at a moment when Britain needed visible success. The cost, 56 dead airmen, 8 destroyed aircraft, seemed acceptable against these strategic gains, though families of the lost might have assessed the equation differently. In November 1945, 6 months after Germany's surrender, Allied assessment teams conducted comprehensive surveys of wartime bombing effectiveness. The Strategic Bombing Survey, established to evaluate whether aerial campaigns had justified their resource expenditure, devoted particular attention to Operation Chastise. Analysts interviewed German officials, reviewed production records, examined rebuilt dams, and calculated actual economic impact. Their findings, published in report dated March 1946, rated the raid as 65% tactical success, 35% strategic. The tactical success reflected achievement of primary objectives. Both Möhne and Eder dams were breached, causing significant flooding and temporary disruption. The strategic limitation reflected production figures showing that Ruhr industrial output declined only briefly. Steel production fell 1.5% in June 1943 but recovered to pre-raid levels by August. Coal output experienced similar temporary decline. Synthetic oil production, considered strategically critical, was unaffected. The raids forced infrastructure repairs and defensive improvements, but did not substantially degrade Germany's war-making capacity. These conclusions disappointed some British officials who had expected more dramatic results. Yet the assessment acknowledged factors beyond immediate production statistics. The forced allocation of 10,000 workers to dam defense represented ongoing strategic cost. The psychological impact, demonstrating that even massive structures could be destroyed, influenced German defensive planning throughout the war's remainder. And the technological innovation, proving that precision weapons could achieve objectives impossible for conventional bombing, influenced post-war ordnance development. Barnes Wallis, invited to comment on the Strategic Bombing Survey's findings, responded with characteristic precision. In a letter dated April 1946, he wrote, "Operation Chastise demonstrated principles, not outcomes. We proved that rotational stabilization could deliver weapons accurately under conditions previously considered impossible. We proved that hydrostatic pressure could amplify explosive force beyond conventional yields. We proved that precision, not quantity, determines effectiveness. These principles matter more than one mission's immediate results." Wallis's post-war career validated his perspective. The bouncing bomb concept, though never used again in its original form, influenced development of depth charges, anti-ship weapons, and later guided munitions. The precision bombing techniques developed for Chastise informed creation of larger weapons. The Tallboy and Grand Slam bombs, both designed by Wallis, which destroyed targets ranging from submarine pens to railway viaducts with unprecedented accuracy. No. 617 Squadron, retained as the Royal Air Force's precision bombing unit, deployed these weapons with effectiveness that fully justified the squadron's formation. Guy Gibson did not live to see these developments. He died on September 19, 1944, when his Mosquito aircraft crashed during a raid over the Netherlands. He was 26 years old. His death denied Britain one of its most celebrated bomber commanders and removed a figure who had become symbolic of British determination. Memorial services emphasized his courage and leadership while omitting mention of the complexities that surrounded Operation Chastise's outcomes. Public memory preferred heroic narrative to strategic ambiguity. The surviving Dambusters crew members returned to operational duty. Some completed their tour rotations and retired from combat flying. Others continued operations and died in subsequent raids. The attrition rate for Bomber Command remained approximately 44% throughout the war. Those who survived to war's end found themselves veterans of an operation that had achieved cultural status disproportionate to its strategic impact. They attended reunions, gave interviews, and watched as their mission was immortalized in the 1955 film, The Dambusters, which dramatized events while simplifying their complexity. The film presented Operation Chastise as unambiguous triumph. Heroic airmen using innovative technology to strike a devastating blow against enemy infrastructure. It omitted mention of limited strategic impact, disproportionate casualties among forced laborers, and debates about whether the mission's cost justified its results. This simplified narrative served post-war purposes, providing Britain with a victory story during an era when wartime sacrifices needed retrospective justification. Audiences preferred clear heroes and villains to nuanced assessments of cost-benefit ratios and strategic opportunity costs. German survivors of the floods faced different memory challenges. For those who had lost family members, the raids represented tragedy inflicted by enemy bombing, an experience shared with millions of Germans who endured aerial attacks throughout the war. Yet acknowledging casualties from the dam breaches meant acknowledging the flood's severity, which conflicted with official German narratives that had minimized damage for propaganda purposes. Many survivors never spoke publicly about their experiences, carrying private memories that did not fit official histories on either side. The forced laborers who died received no memorials. Their bodies, buried in unmarked graves, were forgotten in post-war commemorations that focused on military casualties and German civilian deaths. Not until the 1980s did researchers begin systematically documenting foreign workers' deaths during the floods. By then, most survivors had died, taking their testimonies to unmarked graves that mirrored those of their fellow prisoners. This historical erasure reflected broader patterns in how the war was remembered: emphasis on military operations and national narratives, neglect of victims who fit neither category. On May 17, 1963, the 20th anniversary of the raids, survivors and Royal Air Force veterans gathered at Möhne Dam for a commemoration ceremony. The rebuilt dam stood as testimony to both destruction and reconstruction. Barnes Wallis attended, now 76 years old, still active in aerospace engineering. When asked to speak, he refused to call the operation a triumph. Instead, he said, "Engineers serve duty, not destruction. We built a weapon because we were asked. It worked as designed. Whether it should have been used remains a question for others. I know only that war demands terrible choices, and engineers must live with the consequences of their mathematics." His words reflected ambivalence that official commemorations rarely acknowledged. The raids had been technically brilliant and operationally successful, yet their strategic value remained debatable. 53 airmen died, 3 were captured, and more than 1,000 civilians died. Most of them forced laborers with no connection to German war production. The dams were rebuilt within months. Ruhr industry continued operating. Germany's war effort was barely affected. Yet resources were diverted, defenses were strengthened, and British morale was bolstered. In the calculus of total war, these factors mattered, even if their value could not be quantified precisely. Albert Speer, in his post-war memoirs, devoted several pages to Operation Chastise. His assessment concluded, "The lesson is vulnerability. We learned that no structure, however massive, provides absolute protection. This realization shaped our defensive thinking for the war's remainder. Whether the British achieved their immediate objectives matters less than the fact that they forced us to acknowledge we could not defend everything simultaneously. That acknowledgement, more than physical damage, represented their strategic success." Speer's analysis, written from the perspective of defeat, offered insight that contemporary assessments missed. The raids succeeded not by destroying production capacity but by destroying assumptions about defensive invulnerability. This psychological shift forced resource allocation changes that accumulated over time. Each dam that required protection, each bridge that needed additional flak coverage, each power station that demanded defensive investment, all consumed resources that might otherwise have supported offensive operations. The cumulative effect, invisible in any single monthly production report, contributed to Germany's gradual resource exhaustion. By 1963, this perspective had become acceptable in both Britain and Germany. The war's outcome was settled. Former enemies could acknowledge complexities that wartime propaganda had obscured. Veterans on both sides recognized that heroism and tragedy coexisted in every operation, that technical brilliance did not guarantee strategic success, and that war's human costs always exceeded its operational achievements. The legacy of Operation Chastise extended far beyond the flooded Ruhr valleys and rebuilt dams. Within 2 years of the raids, No. 617 Squadron evolved into the Royal Air Force's primary precision bombing unit, deploying progressively larger weapons against strategically critical targets. The Tallboy bomb, weighing 12,000 pounds, destroyed the Tirpitz battleship and collapsed the Bielefeld railway viaduct. The Grand Slam bomb, weighing 22,000 pounds, penetrated reinforced concrete submarine pens that had resisted all conventional bombing. Each weapon embodied principles proven during Operation Chastise. That precision delivery, properly engineered ordnance, and exceptional crew skill could achieve results impossible through area bombing. These developments vindicated strategic decisions made in early 1943 when Air Ministry planners authorized development of specialized weapons and elite units to deploy them. The cost? 8 aircraft and 53 dead airmen at Möhne and Eder, plus additional losses in subsequent precision operations, was judged acceptable against the alternative of continued area bombing with its lower accuracy and higher overall casualty rates. Post-war analysis calculated that precision weapons delivered by skilled crews achieved target destruction rates approximately 4 times higher than conventional bombing, while requiring fewer sorties and exposing fewer aircrew to defensive fire. Yet this efficiency came with constraints. Precision weapons required extensive development time, specialized aircraft modifications, and intensive crew training. Only a small fraction of Bomber Command's resources could be devoted to precision operations. The majority of sorties remained conventional area attacks against industrial cities. Operation Chastise demonstrated what was possible but could not be replicated across the entire bombing campaign. The gap between elite capabilities and standard operations remained wide throughout the war. This gap influenced post-war military doctrine. Air forces worldwide studied the Dambusters methods, seeking to expand precision attack capabilities beyond small specialist units. The United States Air Force, impressed by British precision weapons, accelerated development of guided munitions, early versions of technology that would dominate late 20th century warfare. The Soviet Union, which had focused exclusively on tactical ground support aviation during the war, established strategic bomber units and began developing long-range precision weapons. Even defeated Germany's aviation engineers, many of whom joined Western military-industrial complexes after the war, contributed expertise gained from defending against precision attacks. Barnes Wallis continued developing weapons until his retirement in 1971 at age 84. His post-war designs included supersonic aircraft concepts, anti-submarine weapons, and earthquake bombs intended to destroy underground facilities through seismic shock. Most never reached production, but all embodied the same engineering philosophy demonstrated in the bouncing bomb. Identify a specific problem, analyze its physics completely, design a solution that exploits enemy vulnerabilities, and test exhaustively before deployment. This methodology became standard practice in post-war weapons development, influencing everything from guided missiles to nuclear weapons delivery systems. The Möhne Valley itself recovered slowly. The rebuilt dam functioned correctly, but ecological damage from the flood persisted for years. River channels had been scoured, farmland had been buried under silt and debris, and forest areas had been stripped by fast-moving water. Agricultural production in the valley did not return to pre-war levels until 1948. Fish populations, decimated by the initial flood and subsequent pollution from destroyed industrial facilities, required restocking programs that continued into the 1950s. The physical scars healed, but complete ecological recovery took decades. Human recovery proved equally difficult. Families displaced by the floods often could not return to original home sites because buildings had been destroyed and land had been contaminated or rendered unusable. German authorities, struggling with post-war reconstruction demands across the entire nation, provided minimal assistance to flood victims. Many relocated to other regions, leaving the Möhne Valley underpopulated compared to pre-war levels. This demographic shift affected local economies for years, as labor shortages delayed reconstruction of damaged infrastructure and industrial facilities. The forced laborers who had died in the floods remained largely forgotten until researchers in the 1980s began documenting their fates. Survivors who could be located, primarily those who had remained in Europe rather than returning to Soviet territories, provided testimony about camp conditions, the night of the floods, and the lack of German rescue efforts. These accounts challenged simplified narratives that portrayed the raids purely as military operations targeting industrial infrastructure. The reality was more complex. The weapons were aimed at dams, but the casualties were disproportionately people who had no involvement in German war production and were themselves victims of Nazi oppression. This complexity has shaped modern historical assessments. Contemporary historians acknowledge Operation Chastise's technical brilliance and the courage of participating aircrews, while also recognizing the operation's limited strategic impact and tragic human cost. The raids are studied in military academies as examples of successful innovation and in ethics courses as case studies of unintended consequences. Neither celebration nor condemnation fully captures the operation's significance. Instead, it stands as demonstration that even successful military operations carry costs that exceed their immediate objectives. Memorial ceremonies at Möhne Dam continue annually on May 17th. British veterans, German survivors, and descendants of those who died gather to remember events now distant enough to permit reconciliation. The ceremony acknowledges losses on all sides: the Royal Air Force aircrews who died executing their orders, the German civilians who died in the floods, and the forced laborers who died because their lives were valued least by those who might have saved them. This inclusive remembrance, impossible during the war and difficult for decades afterward, represents perhaps the operation's most meaningful legacy: the recognition that war's costs are shared by all who suffer its consequences, regardless of nationality or circumstance. From the surface of a reservoir in Lincolnshire, where Lancaster crews trained at wavetop height, Britain learned that precision could break concrete, and with it, the illusion of invulnerability. The lesson applied equally to defensive fortifications and to the assumptions that made war seem controllable. Both proved fragile when confronted with determined innovation. The Dambusters demonstrated that no structure was impregnable, but they also demonstrated that even successful operations could not guarantee strategic victory or prevent human tragedy. These twin lessons, one about capability, one about limitation, define Operation Chastise's historical significance more completely than either the dramatic newsreel footage of breached dams or the sober production statistics showing minimal industrial disruption. In the decades since, precision weapons have evolved far beyond spinning cylindrical bombs. Modern guided munitions use lasers, satellites, and computer processors to achieve accuracies measured in feet rather than yards. Yet the fundamental principle remains unchanged. Identify the target, understand its vulnerabilities, deliver force precisely where it matters most. This principle, proven over Möhne and Eder dams on the night of May 16th through 17th, 1943, continues shaping military operations worldwide. The Dambusters' legacy persists not in any single weapon or tactic, but in the broader recognition that wars are won not by overwhelming force applied indiscriminately but by precise force applied intelligently against carefully selected objectives. What is your perspective on this part of history? Share your thoughts in the comments, because every memory and reflection helps keep the past alive.